So hi, my name's Smitha. I'm about to start my PhD at Berkeley. I got interested in AI for a variety of reasons, basically because originally my motivation was AI has so many applications and ways that you can actually make impact. Recently, I became very interested in the safety aspects of artificial intelligence. How do we make sure that these models are actually robust, given that people are going out and using them? I'm very involved in the Center for Human Compatible AI at Berkeley. I'm interning at OpenAI right now, and yeah, as I said, I'll be starting my PhD at Berkeley in the fall.
Fantastic. Are you working with Stuart Russell there?
Yeah, so some of the work that I've done in the past was with Stuart Russell and Anka Dragan, as well as work done with Tom Griffiths, and before Tom Griffiths in cognitive science, as well as even further before that, some natural language processing with David Baman and Marty Hurst. So recently there's been a lot of concern about the rise of autonomy in AI, and some of this concern has led to a lot of research around how do we reliably ensure that systems follow our orders so that at least in the worst case we can turn a system off, for example, if it's doing the wrong thing. And so there have been various approaches from trying to make the robot's objective such that it's indifferent between being shut off or not being shut off. An approach where the robot can't really learn about the value of being shut off. And another approach is to make the robot uncertain about the objective it's maximizing and make that objective the human, so it's automatically incentivized to listen to the human. I personally think that it's important to make sure that the objective of the system is aligned with the objective of the human, and that more naturally leads to incentives to obedience, because there's sometimes when you don't actually want the system to be obedient to you. Like if you've just made a mistake, I'm in my self-driving car and I accidentally hit manual driving mode, I do not want the car to turn on if I'm not paying attention, sort of thing. And so just these sort of worst case safety measures are not enough. We eventually want the system to have a better understanding of when obedience is the right thing, and maybe there's some sort of worst case for like shutdown. But in general, I think the exciting part is how do we work on actually implementing this framework? We can say we want to align the objectives of the robot and the human, but actually doing that kind of alignment algorithmically is very hard. It's the right framework, I think, but there's a difference between the framework level and the algorithms we actually use to implement it. Right, I think there will be various forms of evidence that the system gets about human preferences. So some of that will come in the form of human behavior, just watching the actual individual human. A lot of that will have to be learning a good prior about what human values are. Like, no one ever says that they really value their left foot, but you do. And so there are these implicit things that should just be learned as common sense priors. And of course, there's also some more interactive feedback you can do with the human when the human's also trying to help teach the robot to help her, right? So I think you can try to elicit forms of communication from the human as well. Yeah, so first, I don't think I actually get a coherent extrapolated volition, because we humans, the average human is probably not going to think about what their coherent extrapolated volition is. So getting to that level is something I'm not sure about yet. It raises a lot of concerns, because basically in our framework, we say the human is the ground truth. What if the human isn't? The human has errors in their own ethical decision making, and we'd like to get beyond that to what our society would get to. So I don't know the answer to that yet. Well, yeah, it's a big problem. And then the other question you raised about aggregating human preferences, that is another thing that is super interesting to me. Again, all of these things suddenly become ill-defined with respect to the framework that we have, which just puts the ground truth with the human, because now it's not the human, but multiple humans. So where does the ground truth lie? We can't just defer to some human. And so that might come from institutional agreements, I think there's a lot to be taken from all the social choice literature here, but I mean, no one really agrees on the best social choice algorithms either. So that also seems in a lot of ways like an institutionalized thing, but I'm not really sure. A lot of people, when they immediately think of ethics in AI, think we should go look at philosophy and then try to implement it. But that, to me, seems actually really hard to do because all the ethical theories are underspecified. But people are trying to, formalize theories, and often the formalization of some of these theories brings up things that you wouldn't have realized the theory implied until you implemented it. So I think just as in some ways AI can be seen as formalizing models of human cognition by actually implementing them and trying to see how they work, some areas of research, then in the same way we can think of looking at philosophy and ethical theories and trying to implement them as our way to see whether those ethical theories make sense in the first place. And then that process of discovering what weird bullets these ethical theories cause that we didn't think of before could be a good way to revise. Another thing that's kind of interesting is that often the arguments between ethical theories are based on certain counter arguments that we're never really sure, how often we would see in the real world. I mean, no one is ever going to run into a real trolley problem, right? But it would be interesting if we can actually implement, in some sense of the word, these sorts of models to see how often they get things wrong. Because it seems like a theory that is 90% good is a lot better, but we might be focusing in on just very narrow counterexamples that cause us to reject it. So that's one way in which I think that as society as a whole, we might end up coming to better ethical theories. I don't necessarily think we'll come up with consistent theories. We might even find a reason for why humans themselves are so inconsistent. It's maybe just because actually implementing these things is very computationally complex, so we need a lot of heuristics. But it'll be interesting to see, can we say something about optimality of these heuristics? Yeah, one thing that people often debate in these AI and ethics debates is what ethical theory is best. Should our robots be utilitarian? Should they be deontological, virtue ethics? But I think this is really misguided because we use various forms of all of these three ethics. And it's not misguided because we do it, but because one reason that we might actually be using a mix of all these theories is simply because we're computationally limited. There's no actual way for us to make perfectly utilitarian decisions, right? And so we often resort to deontological heuristics, and these deontological heuristics are often near misses of what would be the utilitarian solution. So not killing someone is generally the good thing to do, and so if you use that as a rule, it's usually turns out well. And so when people say, should our robots be utilitarian, I think they're missing the point that there's no way we can implement a utilitarian robot. It's just too computationally complex. And so we are going to need to resort to heuristics. And those heuristics are going to come out of the approximation algorithms that we make. So it's important to be able to analyze these approximations to see what sort of emergent behavior arises from them. Do we get discriminatory behavior arising from these heuristics? I think the devil is all in the details here. And so we kind of miss the point when we ask at such a high level what framework we want to implement in the system. Yeah. So there is research that shows that humans seem to be using these different systems, a more utilitarian system versus a more deontological systems, to trade off computational complexity. When you have more computational resources available to you at a certain time, then you tend to make more utilitarian decisions. But when you have less, you make more deontological decisions. And so there's this theory that actually this trade-off between the ethics is based on computation. And you can read, say, Josh Green's work for more information about this. So I've done this work with Stuart on obedience and AI and autonomy. Other things I've worked on stuff related to bounded rationality. Yes. So a theory of meta-reasoning and bounded rationality that applies to humans and AIs with Tom Griffiths. So I am very interested in basically AI interaction with humans and how we can use that to ensure that a system has learned the right objective or the right behavior. Going forward, what I'm interested in working on in my PhD is issues around these interactions with humans and AI systems. So issues like interpretability or the explainability of models and things like fairness, problems that are safety but are immediate and short term that we can see progress on now that I think will still be very useful for progress on long-term safety problems because they involve getting the interaction between systems and humans right, which is just a general problem that is useful at any time scale, I think. So if you've read, say, Thinking Fast and Slow, you know that one popular psychological theory comes from this class of models known as dual process theories. The idea that the human mind is made up of two systems. One system that is fast but error prone, and another system that is slow but more accurate. And the thing you might ask with these systems is, why two? That makes no sense, it's totally arbitrary. And the reason that we think, or that we propose in one of our papers, is that eventually there's a meta-reasoning trade-off. If there were two systems, then this is something that's pretty easy to switch between. If there are like 200 systems, that's something harder if you're trying to pick between each system. So there's kind of this trade-off between the ease of the search problem and what accuracy you'll eventually end up getting out of this. So I think that bounded rationality in general is a very interesting framework for modeling humans because this allows us to share a lot of the work we already do in AI because it's just like an optimizing an objective where there's also a cost of computation added. So it's like, what's the optimal thing for me to do given that each second I think takes up this much computation? And in this case, when we model humans this way, then we'll get back the answers that are solutions to this objective. As we reduce what that cost of computation is, we get, what would be optimal for a machine to do. And so in that way, it's nice because it's kind of this convergent paradigm. There's this good paper in Science, it's like a convergent paradigm for brains, minds, and machines or something, and it talks about bounded rationality by Josh Tenenbaum and Sam Gershman and others. So and in particular, I think for a system to interact with a human well, it needs to have a good model of what humans are like. But getting models of humans is really hard, especially if you try to just make up ad hoc theories about the different types of heuristics humans might be using. There's no way to get some sort of universal coherent theory. But bounded rationality is nice because now you don't need to specify the heuristics themselves. The heuristics fall out of the optimization. You just need to specify what the costs of computation are, and that might actually be a lot easier to specify. And so I think bounded rationality might have a really nice role to play in making our models of humans more accurate that we use in AI systems. I think a big open problem is the algorithmic aspect, at least to some of the stuff that we've worked on in Berkeley. We have a framework for value alignment called cooperative inverse reinforcement learning, but actual algorithms to solve that framework, pretty behind on. But I think there is a lot of rapid progress being made in that direction so that, eventually we'll actually be able to implement these models on robots. But most of that progress has been done on just the robot side. I think that integrating more accurate models of humans in is also a really important component, and I'm very interested in that. In general, in this field, I think there's tons of exciting stuff happening in safety, and I particularly am most interested in the parts that involve interaction with humans, because I think that interaction with humans is a really good way to see whether the system has learned the right objective or the right behavior under a lot of cases. For example, we might not know, a priori, I often think of the Google gorilla incident when I think about this, is the time when Google's photo apps were classifying black people as gorillas, just terrible. A lot of people's reaction to that was sort of like they didn't have the right objective. But there is no way to think up all the possible ways things could go wrong in the future. But at least I think you would like to have some sort of loop going with humans where you could quickly hone in on problems like this. And it's super non-trivial to do because the search space is so large on what could be issues here. But that I think is a really interesting direction. For things that are just inherently ill-defined, like a lot of people are talking about fairness in machine learning, I really think of that as a value alignment problem where we don't know what fair means in different contexts, so we have to learn it. So what theoretical guarantees can we make about our ability to learn? Can we kind of reduce what fairness means a little bit and still get some things out of this? So I think that there's a lot of interesting directions on things that some people have classified as short-term safety research, like fairness, that if put the right way, can actually also be applicable to the long-term research. And I think this is similar with interpretability. A lot of people think interpretability is not really useful for long-term stuff. Maybe not the interpretability that's like, we're just going to approximate this model with a simpler one done naively, but I think the idea of having a system that can communicate what it's doing to you with high fidelity is absolutely a problem that is useful both in the short term and the long term. And so both of these things involve interaction with humans, whether it's a system trying to interact well with a human, a system using human feedback to ensure that it's doing well. In any case, I think that there's just a lot of general questions about how do we make that interaction most well. A lot of papers already pre-specify what the interaction between the system and the human is going to be. Can we start to choose what the optimal type of interaction is? There's a lot of these questions I think are open and super exciting to explore. So this is a bit not research related, but one thing that I would really like to mention is that if you are interested in safety research, there's a lot of places to do it now and a lot of different directions people are thinking of. So I think that more people should work on these kinds of problems of making machine learning systems reliable, making AI safe and beneficial. And I think it's really important to keep in mind all the different sorts of things people are doing and hope that we can, together push this forward in some way. Okay, yeah. So I think a lot of people have this distinction in safety research between the short term and the long term, and they think there's no overlap. But I don't think that's true. I think in general, the whole point of research is that you're trying to come up with generalizable insights that will work on all sorts of problems and last in the long term. But you verify that the things that you think are going to be useful are actually useful through testing it out in problems you can test out now, and hope that because they are so general, or that you've shown that they're general, that they will continue to be useful in the future. And so I think that it's actually, while people make this distinction, I think whether or not your research is generalizable really depends on the way you're conducting your research. So if you think you're doing long-term research, but you really make a bunch of, ad hoc assumptions about specific structure of the specific structure of the systems you're working with, then and your results depend on that, then that seems a bit less generalizable to lots of different problems. On the other hand, a lot of people think short-term research is only applicable to short-term research, but I think it really depends on how you set up the problem. So for example, if you're interested in fairness in machine learning and you just treat this as a value alignment problem, then making progress on this allows you to see that you're making practical progress on a real-world problem, but is also a relevant long-term problem. So I think that we shouldn't focus too much on putting these things into predefined boxes based on just what the motivation section of the paper says, but really think about what the generalizable insights are. And I think it is important to think about the long term. Whatever probability you put on having AI that is super competent, it's probably useful at least to do short-term things that you think would still generalize to that scenario. At the same time, I think even if you care about the long-term thing the most, it's important to do validate your stuff in the short term to keep yourself grounded.